All right, so section P5 is a lot of review of what we did the first week of school. But I'm going to clarify some things, and we're going to throw our calculator into the mix as well. So we are solving equations graphically, numerically. Numerically is example 7, and algebraically. So example 1, and if you have questions, stop and ask, because if you have a question, so does somebody else. And you have to pay attention to whether they want you to graph it, if they want you to solve it using algebra, or this thing called numerically, which is using tables. Because Math Excel will probably have several parts if it's algebraically to make you put in the steps as you go. So this one we are going to solve 2x squared minus 3x minus 2 equals 0 graphically, which implies using your calculator, period. But then they tack this on confirm. Spell correctly, confirm, algebraically. So they're going to have, you sketch the graph, show where the solutions are from that graph, and then they're going to have parts where you have to show it algebraically, all on the same question. So we're going to start off with the graphically. Is this ready to put into y equals? How do I know if it's ready to put into y equals? Everything's on one side, and what's on the other? 0. So we want it set equal to 0 before we can go into y equals, because remember, the solution to the graph is where it crosses the x-axis, and what is the value of y on the x-axis? 0. So we're going to go to our calculator, go to y equals, and you're going to put that in there. So 2x squared minus 3x minus 2. And then it should be a parabola because it's x squared. So hit enter, or graph, sorry. And sure enough, there it is. Now I can estimate, which just by looking at it, but you certainly don't want to do that. What can we do to find out where it crosses the x-axis? What's it called? It's called what? Zeros. So you want to go to second calc, which is in the trace menu, so second calc, and you want to select 0. So either scroll or select 2. And it's asking you for left bound, and here's my blinking cursor. So I want to get it left of this 0. So left would be above. So I'm going to scroll left with my left cursor until I'm above. Hit enter. Now it's asking for right bound. So to get right, this time it would be underneath. So scroll right, hit enter, and then hit enter again for it to guess. And sure enough, it's right there on the x-axis, and my 0 is, let's go ahead and sketch this before, yes.
My calculator's still in that line.
Oh, okay. Go on, based on what we did on Friday, go to second y equals. Some of you have your stats plots are on, so make sure this says off. So if it says on, hit enter, and your on would be lit up, but not the off. So scroll over to off, and make sure you hit enter so that that's the only thing blinking. That should turn, if you go into y equals, that should turn your stats plots off. There should be no plots highlighted up here. Then some of your windows are off, so if you go into window, make sure that the x min reads -10, not a +10. And then the x max is 10, so it should go -10, 10, 1, -10, 10, 1. Usually you can correct that by doing zoom standard, but sometimes it won't correct that. So those are the two things that might be an issue. Okay, so now it ought to graph. Did that work? Okay. Is everybody good? All right, so let's go ahead and sketch this graph. So based upon our first 0, I know that the first 0 is at negative 1/2. So negative 1/2 would be right here. And I want to label it as negative 1/2 or 0.5 since it is on the calculator. I'll allow you to do the 0.5. Then we want to find the other 0. So second calc, 0. So scroll to where you're just below because that's your left hand. Hit enter. And scroll to the right to where you're above. Hit enter. And enter again. And this time it's a nice pretty number of 2. But before we actually sketch that graph, it'd be really nice to know where that vertex is. How do I find that vertex? Remember? Second, calc, minimum, right? Because the vertex is a minimum, I want to choose minimum. If it were a max, I would have chosen max. And so it wants left bound. Well, right now it's on the right-hand side, so I want to go left of my vertex. So hit enter. Now that one's right bound. Hit enter, and enter again. And this is about, 3/4 to the right and negative 3 down. So 3/4 to the right. And we're just doing a sketch, so you don't have to be super accurate, but now we're the ballpark. And so you can write down here x equals negative 1/2, or you can put negative 0.5, comma, 2. So those are your zeros. Now they want you to confirm it algebraically. So algebraically, we would want one side set equal to 0, so that's good. But then we're going to have to factor this. So I'm going to take this and factor it, but there's no greatest common factor. So we're going to go back to it's the harder factoring. Multiply your bookends together, so I've got a 2 and a negative 2. So I'm going to take 2 times negative 2. That goes in my t-chart. The product of 2 times negative 2 is negative 4. If I have a negative product, what does that mean about the factors of 4? I'm going to add them or subtract them. You don't remember this from week 1 of school. Logic would say, I'm going to subtract them, right? So I'm going to subtract the factors of 4. I'm looking for a middle term of negative 3. What factors of 4 subtract to give me 3? 1 and 4 subtract to give me 3. My 3 is negative. That means the bigger of the two factors carries that same sign. What does the sign of the 1 have to be? A positive. So then we want to tack on a variable to those because those are my 2 new middle terms. These 2 middle terms combine to give me negative 3x. So I'm going to write my bookends, 2x squared, and instead of the minus 3x, I'm going to replace it with, now I could put x first or negative 4x first. I like my third term to be positive, so I'm going to choose to write minus 4x first, then plus the x. That way when I factor out a GCF, I don't have to worry about factoring out negative. And then don't forget your last bookend of minus 2 equals 0. So now we can cut this in half, factor out the GCF. What's the GCF of the first group? 2x, out in front of parentheses, divide by 2x. What do I have left? X minus 2. What's the GCF in the second group? Yeah, there isn't one, so it's a plus 1. And technically we're dividing those by 1. And so what do I get? X minus 2. So now they're both the same in parentheses, so I can bring that x minus 2. All right, let's let it actually look proper. My correction tape got all messed up. Hang tight. All right, so this is x minus 2 out in front of parentheses. And then throw what's left over, which is your garbage, into the empty bin. Now what do? Separate them. So we're going to set each of these separately equal to 0. And now solve. So here if I add 2, I get one of my solutions, x equals 2. And here I would want to subtract 1 and divide by 2. So I get my other solution of -1/2. So those two solutions confirm what we saw graphically. So it's just a review of that. Example 2. You ready? So example 2, you are to solve 2x minus 1 squared equals 9 algebraically. So on this one, if we're going to solve it algebraically, normally we would want one side equal to 0. This side's equal to 9. But notice that you have this nice squared binomial. I mean, we could square this out and subtract 9 and refactor and do what we did here, but that's a whole lot more work than what you could be doing. And most of you, if you squared this back out, you get the wrong answer because you'd tell me it was 4x squared plus or minus 1, which is not true. It has a middle term. And we discussed that a couple weeks ago also. But because this is a nice perfect square, this also happens to be a perfect square, but it doesn't matter. You can take the square root of this side and break that 2x minus 1 squared out in front of the radical, and it's a perfect square, isn't it? Since this is a square root, don't we divide this by 2? Which means that I end up bringing out 2x minus 1. But whatever I do to one side, I must do to the other side. So I have to take the square root of the other side, but when you take the square root of a number, it is always plus or minus the square root of that number. Because remember, this is supposed to be squared. I should have two answers. So this plus or minus, the square root of 9 is 3. So we end up with plus or minus 3. Then our goal is still to solve for x, so I want to get that 2x by itself. What do? So add 1, but be careful and add that 1 in front of the plus or minus. Not behind, not with. So you end up with a 2x is equal to 1 plus or minus 3. Now what do you do to solve for x? Divide by 2. The whole thing divided by 2. So because it's all numbers and there's no variables there, we can actually figure out what the two answers are. What's 1 plus 3? 4 divided by 2. So one of the answers is 2. Then we're going to do 1 minus 3 is what? Negative 2 divided by 2? Negative 1. So these are my two solutions. I can actually check that graphically. So I'm going to go over here. This is not equal to 0, however. Oops. That's what y equals. All right, so clear this out. This is not equal to 0, but don't let that bother you. So our original was here in blue. I'm not going to square this out and whatnot to check it on my calculator. I'm going to leave the 2x minus 1 squared just as is. So parentheses, 2x minus 1 in parentheses. And then hit your x squared button to square it. Then if I wanted 0 over here, what would I do? Subtract the 9. Outside of the parentheses, just do minus 9. That's the same thing, isn't it? So now hit your graph. Does it cross the x-axis at 2 and negative 1? Yeah, close enough, right? So I'm pretty assured that my answer is correct. So even though I said algebraically, you're still going to have your calculator available. You can check it graphically. Questions on that? All right, so let's move on to example 3. Example 3, solve, this is a fun one, solve 4x squared minus 20x plus 17 equals 0 by completing the square. So they are going to specifically, although I personally would not choose to solve this particular equation by completing the square, you'll see why in a minute. Math Excel and myself, if I were to give you this problem, would expect to see you using completing the square to solve it. So 2 things are important with completing the square. Number 1, the coefficient of your x squared term cannot have anything there other than 1. So this one has a 4 there. How do I get rid of the 4? Divide by 4. But if I divide one term by 4, I have to divide every term by 4, and unfortunately 4 does not go into all the other terms, which is why I personally would never use completing the square with this particular one, because there's a lot of other things we could use instead. But they did not consult me, so the 4's cancel. I'm going to end up with x squared, and I'm going to prepare this for completing the square for the second step right here. This gives me negative 5x. And when we complete the square, we don't want the constant. Typically, it's not a nice perfect square. So we're going to move the constant to the other side by doing what? Subtracting it. But I'm going to put in here that plus blank, because I'm going to put something there that's a nice perfect square, equals, we subtracted the 17/4 from both sides, and I have to put another plus blank here, because when I complete the square, what I do to one side, I must do to the other side. And this is 100% of the time a plus. When you have a perfect square trinomial, which is what we're creating on the left, the first and last terms, your bookends, are always positive. The only sign change would be in the middle. This could be a positive or a negative. Question so far, does that look familiar? Except for maybe the dividing by 4 part you might have forgotten about. All right, so now we're going to complete the square. So then the next step is to find c. So this is c, your constant. That is b divided by 2 and squared. So we're going to take our b, we're going to divide it by 2 and square it. So our b right now, isn't it, technically it's negative 5. You can put a negative 5 in here if you want. I just always put a positive because I know it's going to come out positive. You can put the negative in there if you want. I'm just afraid that you'll forget and keep the sign a negative. So what is 5 squared, 5 half squared? 25/4. So I'm going to put a 25/4 on the left of the equal sign and a positive 25/4 on the right side of the equal sign. So I've maintained my balance. Now the whole purpose of the completing the square is that you have created a perfect square trinomial here. Your bookends should be perfect squares. And the purpose of that was so that you had this lovely squared binomial, just like we had in example 2. The middle sign here, is always whatever the middle sign was there. So the middle term, middle sign. Because the middle term had a negative, the sign in the middle here is a negative. If this had been a positive 5x, we would have a positive here. What's the square root of x squared? X. So you might want to write yourself a note that we got the x from taking the square root of that x squared. And what's the square root of 25/4? Square root of the top is 5, square root of the bottom is 2, so 5 halves. And I'm going to put an arrow there showing where that came from. Then equals. Fortunately, I'm going to add these together. Fortunately, they are like denominators. If they weren't like denominators, you'd have to find the least common denominator. Opposite signs subtract and keep the sign the larger. So what's 25 minus 17? 8, and it's positive. What's positive 8 divided by 4? Which gives us a nice number of 2. Now, doesn't this look like the problem from example 2? Nice squared binomial here. Don't worry, it has a fraction. So we're going to do what we did in example 2 and take the square root of the left and plus or minus the square root of the right. Yes? The square root of 25/4. So we took the square root of the numerator and the square root of the denominator.
Oh, okay.
And you have to take square root of both of them.
Taking the square root of that.
Yep, so we took the square root of the bookends and they went in here. The middle term gave us the middle sign. Is everybody good to go for this so far? Okay. Uh-huh. Yep. And then the square root of this is just 1 x minus 5 halves equals, I cannot take the square root of 2, so it remains plus or minus the square root of 2. Then how do we solve for x? The square root of 2, because when I took the square root of the left side, to break apart the squared binomial, you have to do plus or minus the square root of the number on the right. What I do to the left side, I have to do the right side. So the red part wasn't there originally. So our original problem from here to here was just x minus 5 halves squared. Just like we did in example 2 previously, we took the square root of that because since that's the square root, aren't I really dividing that by 2? And that's why I get one of them. If I take the square root of left, I have to take the square root of right, but we do plus or minus because I know this should have 2 answers because its highest degree is 2. I have to get 2 answers. Yes, because when you complete the square, we only do it with a quadratic, which is to a high degree of 2. Does that make sense then? Okay. Are we all good? So now to solve for x, we are going to add 5 halves to both sides, but remember you add that 5 halves in front of the plus or minus. And your final answer is x equals positive 5 halves plus or minus the square root of 2. I'm satisfied with this answer, me personally, and that is 2 different answers, but Math Excel will probably want you to split it out. One answer will be 5 halves plus the square root of 2, and the other answer will be 5 halves minus the square root of 2. Those are the 2 roots. That's where it crosses the x-axis. That's the exact answer. If they wanted you to give the decimal equivalency, they'll tell you so. Question?
You took the square root of the x and x
You-
squared is 25 fourths.
I took the square root of the x squared to get the x, and the square root of the 25 fourths to get the 5 halves.
So you do that every time?
Every time I make this perfect square trinomial by completing the square.
Okay.
Because this step here, immediately the next step is to go down into 1 squared binomial, because the purpose of completing the square is to create this perfect square trinomial. And the factor pattern for a perfect square trinomial is 1 set of parentheses squared.
Well, it's roughly negative 5. It's disappeared.
It disappears, because if you go and FOIL this out, x minus 5 halves times x minus 5 halves, and you FOIL that, the inner and outer terms are going to add to give you a negative 5x. They will.
Okay.
Promise they will. All right, so example 4. So for example 4, you've got solve 3x squared minus 6x equals 5. And they want you to be using the quadratic formula. So if you recall, your quadratic formula is x is the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Isn't math so much more fun when we sim when we do it? Let those two pop goes the result. You'll never forget it. The opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Yes, it does. Didn't I just sing it and prove it? I totally did. I may not be the next American Idol, but I just sung it and proved it. Now, every YouTube video online is wrong that I found. They always say negative b. This is not negative b. It's the opposite of b. Because, as you'll see in this example, this turns out positive, not negative. So here's what we're using quadratic formula on. Is it in the correct form for using quadratic formula? No. What has to happen first? You must have one side equal to 0 before you determine what a, b, and c are. So we've got 3x squared minus 6x. Subtract the 5 from both sides, you get minus 5 equals 0. Make sure that these are in descending order. Then I want you to get in the habit of listing out a equals, b equals, c equals. What does a equal? 3. What does b equal? Negative 6. And what does c equal? Negative 5. Make sure that you pay attention to your signs. So now we're going to prepare our formula. Remember, I'm really big on templates. So I'm going to replace every a, b, and c with parentheses. So x equals the opposite of b plus or minus the square root of b squared minus AC all over 2A. I know some of you are looking at me thinking I've gone crazy. Just have fun with your math. You could actually drive your parents crazy by singing that song over and over and over again to annoy them, and then they'll have to learn it too. So now all that's different is that your parentheses have replaced the A's, B's, and C's, and I do that on purpose. So B is -6, so we put a -6 in here, and then this is B squared, so a -6 goes in there. Then A is 3, C is -5, and A goes again down here, and that's 3. So now perform your math. The opposite of -6 is +6, plus or minus. -6 squared is +36. When you get to the 4AC, it is imperative that you count negatives. How many negatives are there? 2. So the sign between the B squared and the 4AC is actually positive. Then ignore the signs and just multiply. 4 times 5 is 20, times the 3 is 60. All divided by 2 times 3 is 6. So this equals 6 plus or minus, what's 36 plus 60? 96, all divided by 6. Now we need to simplify our radical. Using divisibility rules, I know that 4 goes into 96, and it goes into 96 24 times. I know that 24 has another 4 in it, 4 times 6. You could go down to the primes, but why? Don't I have a pair of 4s? Right? So I can take a 4 out in front, and the 6 doesn't have anything to pair up with, it stays underneath the radical. So I get equals 6 plus or minus, the 4 comes out in front, square root of 6 stays underneath, all over 6. We're almost there. The last thing you have to do is look at what I call your triangle Superman of numbers. If there's not a number here in front of the radical, what is it understood to be? A 1. You have to take that into account. When you reduce these numbers, all 3 have to have a common divisor. And if there was a 1 here, you would not be able to reduce the 6's. You also can't reduce the 6's here because one's under the radical and one's outside. They cannot communicate with each other. So now look at all 3 numbers. What do they all have in common? A 2. So 2 goes in here 3 times, in here twice, and in here 3 times. So your actual final answer, x equals 3 plus or minus 2 square root of 6 all over 3. I will accept this as an answer. Math XL, most likely, they want the exact answer, will want the following 2. 3 plus 2 radical 6 over 3, and 3 minus 2 radical 6 over 3. Those are the 2 exact answers. That's where this graph crosses the x-axis. And we could calculate that decimal out on our calculator and check it if you wanted, but we're going to skip that on this one. So are we good with our quadratic formula? Yay! Bless you. All right, example 5 you'll like. It's simple and quick. So example 5, did I flip too quickly? Are we good? Okay. So you're going to solve x cubed minus x minus 1 equals 0 graphically. Just graphically. Okay? So take your handy dandy calculator. Is it ready to be put into y equals? Yeah, it's set equal to 0, so put it in as is. X, you're going to have to use your caret to the third, then use your right arrow key for the newer calculators to get it out of the exponent. If you have an older calculator that shows the caret, you don't have to worry about that. Then minus x minus 1. And the graph should look like an S curve, not a parabola. So it should look like that. If yours doesn't, or if you have a syntax error or some sort of error code, let me see your calculator. Everybody good to go? Okay, if somebody next to you doesn't have a calculator, share yours with them so they can see what you're doing. How are you going to find the solution? Oh, let me stop you there for a minute. the highest degree term in this polynomial is what? It's a polynomial of what degree? Third degree, right? How many solutions does that mean? There could be 3. How many solutions are there? How many real solutions? Only 1, because it only crosses the x-axis once. That means if I have 1 solution, what are the other 2? Imaginary. And if you recall, imaginary solutions always come in pairs. So that makes sense. Okay. You're not required to find the imaginary though. All right, so how do I find that? Where to go? Second, calc, what? 0. So choose 2 or scroll down to 2. So you want to get left down, which in this case is underneath. So I scroll till I get underneath, hit enter. Scroll till you get to the right above, hit enter, and enter again. And we get a value, and we're going to write down the exact value. X equals 1.324718. Probably a estimated decimal on the calculator's part. But I'm going to teach you how to find this using tables, not looking at the graph, and getting exactly the same thing, but we're only going to round to 2 decimal places, because here I want you to write down the book's agreement with you on rounding. So they are stating a specific agreement on rounding that you need to know and follow. So if I were you, I'd write this down. Agreement about approximate solutions. So they're specifically explaining to you how they want you to round. For word problems, they refer to them as application problems. Those are word problems, comma, round to a value that is reasonable for the context of the problem. So this isn't all of it, this is only half of it. So what they're saying is whatever seems reasonable for that problem. If there are decimals in the original word problem, you round to whatever they round to for those decimals. It's called significant digits. If there's no decimals in the original problem, but it makes sense for you to use a decimal, then I would typically round to 1 or 2 places, or whatever seems reasonable. That's what kind of leaving a little bit open. For everything else, and here they go, for all other, problems, comma, round to 2 decimals. Oh, sorry, 2 decimal, singular. Round to 2 decimal places. Unless directed otherwise. Lawyer must have written this one right. So if there's no mention on how to round, and they say to estimate, but there's no mention, then it's assumed it's 2 decimal places. And that's typical practice for most mathematicians. All right, so example 6, we're going to need that. For example 6, we're going to need some room. Solve using tables. This actually has a fairly useful tool, and we're going to solve exactly the same problem that we just did. So we already know the answer. But I'm going to show you we can arrive at that same answer using tables. Remind me to have you change your tables when we do this. So write down the following instructions before I show you. So write these down. You are going to change table set in your calculator to you want it to read auto, auto for both the independent and dependent variable. Remember, we switched that for some of you. And you want to change where it says a little triangle table, you want to change table. You want to convert that to 0.1, and that's your start for now. We're going to start there for now, because we're going to adjust this change table part. This is what we keep changing to get a better and better estimate. And so we're going to do that. As soon as you have that written, we're going to change it in our calculator. All right, so we're going to go into table set. So second, click out of here, and go into second table set. So most of you, your table set will say start at 1, and then this is 1, and then this is ask and auto. So we'll still start at 1, that's fine. Change table, let's change that. So scroll down and change that to 0.1. I'm going to go by tenths. And then change this to auto. So click on it and click enter. So all auto should be lit up. So is everybody there? Okay. So then go into second graph. It'll bring you to our tables. And if you think about where the 0 occurs, look at the graph itself. The 0 occurs here. We're going to look at what happens as x comes this way. The y value is negative, right? Until x, the y value is always negative until we hit 0. And all of a sudden at this 0, doesn't the y value as x continues on this way, doesn't the y value become positive? Every time there's a 0, there's a change in sign in y. And that's what you're looking for in the table. So second here. Because of the work we already did, I know that there's a change somewhere around 1.3. True? So I'm going to scroll on my table. We look down here. At 1.3 to 1.4, isn't there a change in sign? So we're going to write exactly what this table says. I'm going to write it down. So we've got x and y. Just going to record what the table says. My table says at 1, I have negative 1. And at 1.1, I have negative 0.769. At 1.2, I have negative 0.472. At 1.3, I have negative 0.103. 1.4, I have 0.344. And we'll do one more for chuckle's sake. 1.5, I have 0.875. So I really want to capture that sign change, which I did right there. So that's my first start of my estimate. So I know, write yourself a note, sign change. Here. We're looking for that sign change. Delta means change. And so that means my answer is between 1.3 and 1.4. That's what that tells me. Somewhere my 0 is in between 1.3 and 1.4. So we want to make our estimate even more accurate. So this table set was at delta table equaled 0.1. Now we want to do delta table at 0.01. We're getting one more digit of decimal accuracy. And so we're going to go into table set and change it again. So second table set, just scroll down to change table and change that to 0.01. Okay, we're going to go to second table and look at our table now. So it's starting at 1. I'm going to scroll until I get a sign change. And I know I'm scrolling looking for 1.3 because that's where the sign change occurs. Somewhere in 1.3. Still negative. Still 1.1, 1.2, 1. There's my 1.3. So I'm going to put 1.3 at the top. And here's where my sign change occurs, right here. Between 1.32 and 1.33. But they're not the same decimal yet. When these become the same decimal, you can stop. So let's record what that says. X and Y. So I've got 1.3 is at negative 0.103. 1.31 is at negative 0.0619. 1.32 is at negative 0.02. 1.33 is at positive 0.02264, and one more for chuckle's sake. 1.34 is at 0.0661. Straight off my table. Again, I'm looking for that sign change. Here it occurred. So this is your sign change. Sign, wow, sing. You're gonna sing. How about sign change? And so that means that my answer is between 1.32 and 1.33. When they're not the same, we have to keep going. So what am I going to change my table to this time? 0.001. So we're going to change this second table set. I'm going to change the change table. Whoops, I missed it. 2.001. Second table. I know it occurs at 1.32. There's my positive sign change right there. So I'm going to write those down and we'll be done. So I'll show you while we're done. So let's look at, scroll this up. So let's record these, x, y, flush you, flush in. So I've got 1.322 is at negative 0.0116. 1.323 is at negative 0.0073. Notice that it's getting closer to 0 on the y side. And then 1.324 is at negative 0.0031, closer to 0 even still. 1.325 is at 0.0012, and that's where the sign change occurs. So one more, 1.326, and that's at 0.00547. So because I only want to go out to 2 decimal places, and you can now see that that's where the sign change occurs. And then notice that out to 2 decimal places, the 1.32 is 1.32 in both of those numbers. So that's how I know to stop. And so therefore, x is approximately equal to 1.32 because we rounded to 2 decimal places. And isn't that the estimated answer from number 5 above? If we rounded that to 2 decimal places, wouldn't that have been 1.32 as well? Last question. Can I flip that? Almost. You good? Nobody's complaining? Okay, last question. All right, so example 7. I don't like how the book wants you to do this, so you're going to do it my way, because I just think it's kind of ridiculous. You're going to solve, they're going to ask you to solve by finding intersections. You're not going to do it that way. So if you have issues with Math Excel, just screenshot it to me and I want to see what they're asking. So we've got absolute value of 2x minus 1 and of absolute value equals 6. So on your calculator, this is how you're going to put absolute value into y equals. So on your calculator, you're going to go to y equals, okay. Then you're going to select math. There's a math button below the alpha button on your calculator. So you'll select the math button. And then from there, you're going to scroll right to the number menu. And from there, you will select ABS parentheses. It will look different on the older calculators and the newer ones. The older calculators, it will keep it ABS parentheses, and then you have to close the parentheses. On the newer calculators, it shows the absolute value sign. So, in here, first of all, let's fix our table set. Let's go back to second table set, and I want you to start at 1, hit enter. Change table should be 1, hit enter, and then change auto to ask, hit enter. Then go to y equals. Clear that out. And now we're going to find our math button. So here's our math button. So click on math, it's right below alpha. And see how I can scroll over to numbers. I have a menu within that menu, so scroll over to numbers, and I'm going to choose absolute value parentheses. Now my calculator puts the absolute value signs in there. If you have the older calculator, it actually says ABS parentheses. Then you'll put in, just like me, 2x, what are you doing, -1, -1, and then you will end your parentheses if you have the ABS parentheses. We are just going to right arrow out of the absolute value. And then I want this set equal to 0, so what do I put here? -6. So in my calculator, I'm putting in y equals, I'm putting in absolute value of 2x minus 1 -6, because we want that equals to 0. And so now hit graph. Can't you just use your zeros and find where it intersects the x-axis? So I know you know how to do that. So your answers for x turn out to be -2.5 and +3.5, because your calculator is going to give you decimals. Now here's what your textbook wants you to put into y equals. Instead of this, they want you to put in just the absolute value, and they want you to put in the 6, the right side, as another horizontal line, just 6 here. And you can find the zeros the same way, by finding the intersection of those two lines, but there's no point when you can put in the proper equation and get what it really looks like, and just find the zeros. So if you run across an issue with that question, just screenshot me the question, and we'll discuss how you're going to answer it. So your homework tonight is P-5.